Unit 1, Part 1 of 1.3. Decimal fractions. Please note that decimal fractions are just a different way of writing fractions. Let's look at the following number. I would read it 61.88, meaning that the numbers after the decimal point, you read the digits one by one. This is my whole number, my integer. There is my decimal point. Or in South Africa, we also use a comma. These are my decimal values, in other words, my fractional values. So the 0.88 we can write in different ways. You can write it as 88 over, then you put a 1 and you say there are 2 decimal digits, so you put 2 zeros. Or you can say this is the same as 0.8 plus 0.08. Note the 0. And that would be 8 over 1 with a 1 0, because it's got 1 digit, plus 8 over a 1 with 2 zeros. So can you see that those two 8s are not at all the same value? 8 over 100 is 10 times smaller than 8 over 10. Remember the idea of the pizzas. In the one we sliced the pizza only into 10 slices, with the other one we sliced it into 100 slices. 10 times smaller. Let's look at another decimal number. So I would read that 74.516. The 5 is 5/10. 10 with a TH. The 1 is 100th. So if you put the TH, it's got a completely different meaning to when you don't put the TH. And the 6 is 6,000ths. Right, now we're going to look at the rounding. Rounding is a similar value, but less exact. And there are different situations in which we need to round. A good example is the value of pi. Pi is 3.1415926535, and it goes on forever. So actually we can never write the exact value of pi because it's a never-ending number. Notice your decimal point there. So if we want to use pi, it depends on how delicate our situation is, how exact we want. If you want to paint a big circle with a radius of, let's say, 1 meter, then you don't need to have it the area exact to about 6 decimal places. That's not necessary. you're not going to work out how much paint you need to the very last drop. But if you are a scientist and you're working with bacteria, which are very, very small, then you do need a much more accurate value, so you would round it to more decimal places. Okay, I'm going to do an example on this one. So, in one case, round to 2 decimals. In one case to 3 decimals, and one case to 5. Notice this, significant figures. That's a different question. Still rounding, but different rules. Okay, when you've got to write it to 2 decimals, you start by writing it to 3. The last decimal is one that you are going to discard. But it tells you that once you've written it to 2 decimals, it tells you what happens to the last man standing. So you look at the value of this guy. It is smaller than 5, meaning when I only write 2, then the last man standing stays a 4. Let's see to 3 decimals. You first write it to 4. This one is larger than or equal to 5. So even though we're going to discard it, it means and I missed my 1 there, my last digit, my last man standing won't be a 1 now, it will be a 2. It gets more. The difference with significant figures means you don't start counting after the decimal. You start counting at the 3. And you write 6 digits now. 1, 2, 3, 4, 5, 6 digits. You look at this last one. It is greater than a 5. That means my last man standing gets 1 bigger. So the last remaining one never gets smaller. It either stays the same or it gets 1 bigger. Good. We will continue. We will do another example when we start with part 2, just to make sure you've got the rounding and you understand it.